want to just start the recording, that's all. Okay, we are good to go.
Dina, does everyone need to consent to the recording? Did that pop up on everyone's screen, or?
I mean, it's only us that are being heard, so it's just
okay. Gotcha.
So I'm going to turn off my camera and I'm going to go away.
Just make sure that if anyone had that pop up on their screen, we already talked about authorization, but just consent. Otherwise, I don't know if the system continues. Okay, so we're going to go into our first presentation, and I'm very pleased to welcome Dr. Charles Gerba, who is the Professor of Epidemiology and Biostatistics at the Department of Environmental Science at the University of Arizona. He's going to be speaking to us about the survivability of the COVID-19 virus in water, wastewater, and on various surfaces. Professor Gerba is an internationally recognized expert on methodologies for pathogen detection in water, food, pathogen occurrence in households, and the risk assessments of said contaminants. With that, I'll welcome Dr. Gerba to start speaking.
Yeah, thank you. I'm located at the West Center in Tucson, Arizona. We're actually adjacent to a wastewater treatment plant. And the object of the center is to study the long-term quality of wastewater, advanced treated wastewater for reuse purposes and environmental enhancement. The next slide, which somebody's going to have to move for me. I just want to talk about coronaviruses. Thank you. Coronaviruses, we've actually been studying them since 2003 in the original SARS outbreak, because it was known to be excreted in the feces, and there was a concern about getting it into water, wastewater, and its survivability. It's an interesting virus, and it's very simple. It's an RNA virus is enclosed in a protein capsid with lipid around it. Fortunately, this lipid makes it very susceptible to disinfectants because it is very easy to damage in that. Can I have the next slide? I think, yeah, thank you. There are really about 5 major types of human coronaviruses. 2 of them on the left is listed the name, and on the right is listed what it causes. Common coronaviruses, 229E is one of the most common coronaviruses, and it causes the common cold. These 2 coronaviruses cause about 1/3 of the common colds, it's believed, every year in the United States, but there's no mortality associated with them. Now, SARS, the severe acute respiratory syndrome, came about around 2003, and it was a concern because there was a high mortality with this. About 10% of the people died who got this. Fortunately, the virus did not survive very well in the environment, and so it quickly disappeared as a illness in the world. MERS, the Middle Eastern Respiratory Syndrome, is even, in terms of mortality, even worse. About 30% of the people who get this die. Fortunately, it's not spread very easily again from one person to another. But the current SARS-CoV-2, though, is much more hardy than these other viruses, and it's more easily aerosolized, interestingly, it's been found out, than the other coronaviruses, and it's more stable in the air, apparently, than these other coronaviruses. So that's probably one of the reasons it's being spread so much. So let me go to the next slide, if you can. It's excreted in the feces, actually, this virus, for up to 5 weeks after infection. That's the interest from water and wastewater. It's going to be excreted for quite a long period of time. And the virus actually can replicate in the feces, in the intestinal tract, and be excreted. So that's one of the concerns with it. We don't really know whether this virus is infectious in the feces or not yet, conclusively. 2 studies in China say they could find infectious virus in the feces. One study in the US said no, so there's some debate. Currently, it's being detected in the feces using molecular methods. We're detecting the RNA, but we can't tell whether it's alive or dead. There's a lot of work going on around the world today. Probably hundreds of samples are being collected now every day of wastewater, looking for the organisms, largely more from the standpoint of trying to get an estimate of the number of cases of the coronavirus in a community, because you can tell whether interventions are working or not by the amount of coronavirus in the wastewater. You can detect the coronaviruses if you only have 2 or 3 cases per 100,000 people. It's been found out in the Netherlands. So it's a very sensitive technology. Actually, we've seen an increase in March and a decrease once stay-at-home orders and social distancing went into effect. So at least in terms of the number of infected people, we can see that. And basically, the public health people hope to use this data to look at it to determine success in controlling the coronavirus over time. But right now, we don't believe wastewater is a source of transmission. We don't believe that the virus is capable of surviving advanced treatment. We haven't been able to detect it after advanced wastewater treatment here in Tucson. The methods currently, we know there's greater than a 90% reduction of the virus during wastewater treatment. We think it's far greater than that, but the technologies we're using are just being developed, so it's difficult for us to tell much more than that now. It tends to be associated with the solids in wastewater when they settle out. It tends to go with them largely because it's a lipid virus. The concern then now is, will it survive treatment of the solids, the sewage sludges and that? We believe that won't be an issue because it's very sensitive to temperatures. It does survive well at lower temperatures, but not at higher temperatures. And sewage sludges are usually digested, which causes an increase in temperature. Can I have the next slide? This gives you an idea of the survival of the human coronavirus 229E. We looked at that after the SARS outbreak here in our work. And the idea here was to compare that and a feline calicivirus, because that was available too. And then we compared it with PV1, which is poliovirus type 1, which is known to be a very hardy virus. It survives well in water and sewage. And you can see the difference here that the coronaviruses become inactivated readily, maybe a survival time of only significantly of a few days, where the poliovirus survives quite well at room temperature for many weeks in that. So we don't believe that water is a potential route for this virus. It's just a short survival time. Can I have the next slide? This slide really is a different way of presenting the data. The same virus is looking at primary sewage and treated sewage effluents. Again, we don't really see any survival much beyond 3 days. So we believe, again, sewage, wastewater, water, this virus is not going to survive well compared to viruses like polio, again, which survive very well. Okay, next slide. I want to talk a little bit about surface contamination. I think you've seen all on the news about hand hygiene, washing your hands, using hand sanitizers, because viruses like coronavirus and other respiratory viruses can be spread effectively by getting it on your hands and bring your fingers to your eyes, nose, or mouth. And that's the concern with with hand hygiene on this. Survivability varies a lot, though, on how well it will survive. It depends on the humidity. Usually a certain humidity range, and it's been shown already for the new coronavirus, is optimal for its survival. Air temperature doesn't like warmer temperatures. UV light damage can kill it, and other organisms like in water can destroy it. And it survives better on hard surfaces than porous surfaces generally, and if moisture is present. Can I have the next slide? This gives you an idea. This is an inactivation curve, but basically the higher the bar here, the longer the virus survives. And this compares influenza with rhinovirus, which causes the common cold, and some other viruses which cause colds and minor flus. And you can see the coronavirus is somewhere in between. The new coronavirus fits fairly close on the survival to surfaces, as do the other coronaviruses. So it's kind of in between. The only thing unique again about this virus is it does survive better, apparently, in the air than the other coronaviruses. Go to the next slide. One of the issues that we study is how efficiently can you pick this up on your hands. The concern is with people working around wastewater or people who might be ill, what is the transfer from your hand? How efficient is that? If you touch a surface, how many viruses are going to get on your hand and fingers and that? It's really important to know that, because you're going to bring your fingers to your face, an adult, anywhere from 15 to 24 times per hour if you don't recognize that. And you do it more often, actually, when you're eating than any other time of the day. Can I have the next slide? This gives you an idea using a bacterial virus, which we put on a surface and we had people touch it to see how much got on their hand. And of course, this transfer to your hand is related to relative humidity. The red is low, the blue is high relative humidity. You can see if a hard surface like acrylic, glass, formica, stainless steel, you get a very good transfer to your fingers, where other surfaces like money, cotton, polyester clothes, you don't get a very good transfer. And so the concern here is how should we be targeting our disinfecting and cleaning processes, particularly around wastewater plants and that. And basically any hard surface you want to certainly use disinfectants on, because that's where the risk is really the greatest all the time. Have the next slide. Again, this reiterates some of the things I put here too. The concentrations are very large that are excreted by a person. A person can excrete really 100 million viruses per gram of feces. So the amount of viruses excreted, again, the evidence is not sure whether these viruses are infectious or not in the feces, but large amounts. Just think about that. I'll give you an idea. The average bowel movement in the United States is 150 grams. So you can multiply that by 100 to get an idea of how much is being excreted. So a large amount. So that makes detection techniques very sensitive to know how many cases are in a community. Recent data with the COVID-19 virus indicates it can survive 2 to 3 days on plastic and stainless steel surfaces, only about 4 hours on copper surfaces. Copper is very antiviral, and so copper, zinc actually, and silver are all antiviral, but data now is available for the new COVID-19 virus. And it can survive for at least 3 hours in aerosols. A newer paper just published yesterday said it could survive up to 16 hours in aerosols. So that's probably one of the reasons so readily transferred. Now, concern with aerosols is its survival in indoor environment, but remember, if there's a lot of airflow or outdoor environments, it's going to be diluted very rapidly, probably below levels that might be of concern. But no evidence yet for transmission by feces of the virus. That's important to emphasize. At least nobody's been able to document that yet. Can I have the next slide? What we're doing here, we've been involved quite a bit on looking at COVID-19 virus a lot. Largely, we're monitoring its occurrence in wastewater. We saw the levels go up. We saw them go back down now with the social distancing now, but and we're looking at the ability of this virus to do sewage sludge survival. We're not certain, we believe it will not survive, but everybody wants the confidence to show the data. And then we're looking at the treatment processes at various wastewater treatment plants, not only here in Arizona, but across the country and in Canada now, looking at the ability of treatment processes to remove it. We're very confident that the disinfection and other processes will eliminate the viruses, but everybody wants the confidence of this, knowing that for certain, and that's one of the things we're doing. We're emphasizing chloramine disinfectants here because they're used in reclaimed water systems in Arizona that might go on lawns, for example. They're not used for, the chloramines are removed before it's discharged into Riverine area behind us here. But since it's used for distribution system for reclaimed irrigation, and there's no data on that, people wanted concentration time values, so they wanted the assurances that the coronavirus could actually be killed below detection levels. And then we just initiating a project this week on bioaerosol detection at sewer operations. They're concerned with workers, exposure by sewage, and they want the confidence that their protective gear is adequate to prevent them from any aerosolization in the sewer lines that may occur. Thank you.
Okay, thanks for that. So we'll be taking any questions that we have for Dr. Gerba. And please use the Q&A. You'll see it across the bottom of your screen. So Charles, and I was making a couple of notes while we're waiting questions to come in. So one of the questions that I've often I've had posed to me is by, guys who fish in the river or are looking at canoeing in spring and summer here. But just based on what you were saying, that seems like a relatively low risk. Even if you had a SSO release or something like that, it seems that these risks.
Yeah, we believe it's a low risk. Water transmission hasn't been shown, and it seems unlikely. I really wouldn't see where it would be. It would be a low possibility, unlikely, and that I don't really see. I remember years ago, actually, even fish. We did a lot of work on growing fish in wastewater ponds in that, and we looked at what were the risks to people if they actually went fishing in these ponds or utilized the fish, and it was really almost non-existent because the fish don't really take the virus up. The human viruses, they don't replicate in them. So the viruses were not really a concern of that. In some parts of the world, they grow fish in sewage ponds, and that.
Yes.
So a lot of work was done on that, or we did, and the risk was really was considered minimal. Of course, I think if there is a concern, you should probably use good hand hygiene. That's always the risk. We're always worried about if you handle, in the operation we did, handling the fish and processing the fish was really the issue that we had. So,
yeah. A more likely entrance for a virant than the wastewater itself.
Right, that's right. Yeah.
So okay, so we have another question. Do we know how many virons or what concentration of virons is required, say in aerosol form, to infect someone?
That's a good question. We don't have data on the particular COVID-19 virus, but previous work with SARS and the coronavirus called the common cold indicates somewhere between 50 and about 300 viruses are necessary. So you need quite an exposure to it. So somewhere between 50 and 300 viruses really need to get to your face is what it really needs to do.
And I guess I'm adding this bit on the question. If you sneeze or cough or just breathing, are those, we have to assume based on what we're seeing in terms of transmission that those numbers are not uncommon in somebody who would be infected.
That's right. Somebody sneezing or coughing, you can inject hundreds of thousands of viruses by sneezing and coughing. There's quite a bit of this coronavirus in secretions in your nose. When you're actively infective with the virus, you're going to be sneezing and coughing out large amounts of it in droplets. How well aerosols transmit that is not quite really understood yet. There's still not enough data. That's why encouraging people to wear masks and face is a lot of it is to protect other people. If you sneeze or cough and you're infected, now after you're well, you will excrete the virus in your feces for a couple of weeks oftentimes. So the other question, do you see people wearing masks around aeration tanks and that, like N95 masks? It's not really done typically right now, and believing that the virus probably is inactivated very rapidly and not knowing that it's present in sewage, it's probably not necessary at this time. There's no really evidence that there's any route of transmission. There are a lot more viruses I'd worry about in the wastewater than the coronavirus, like norovirus, which causes diarrhea, or hepatitis virus. In that. So I think at this time, it's not recommended. Now, for people working in sewers and that, Kybak suits and other things, because there's a lot of other agents besides coronavirus you're a lot more worried about, like hepatitis A again, and many other types of viruses that are present in the wastewater. So right now, it's believed standard protective gear is all that's needed for wastewater operators.
Okay, and that answered, we had a question, right, you preempted, which was about face masks, etc., around aeration tanks.
Yeah, we're going to be doing studies on aerosols around wastewater plants to see if there's much aerosolization of this virus and determine whether it actually could be infectious. So we're going to be actually starting that work this week.
So I have a question here. I'm going to read it out because it's a little bit longer. And it's from one of our municipal members, and they have a contract with a firm to televise their sanitary sewers. And they've stopped the work, but the firm continues to work elsewhere in the country, and they are asking the municipality if they could restart at the village. So the question is, are the village's actions consistent with science, or is it possible that there could be, or is there a right that they could restart the work, essentially is what they're asking?
Yeah, I think at this time with the stay-at-home orders, it's only done at really is on a need basis is probably what it would do. We believe that, um, protection for work, if it's adequate in water and wastewater, is fine for doing that. But the only reason I'm here at work is because I'm working with coronavirus and I've been given an exception. But even we work in shifts now, so only two people are allowed to work in a laboratory at one time now with the stay-at-home order. So one group comes in early, another group comes in later, and another group comes even later. So that's how we work. We've been able to work around that. So the thing is to minimize the risk as much as possible, because we're still gathering information on what adequate protection and gear and what type of operation should be allowed to be done at this time.
So, and they did clarify, they're obviously once the stay-at-home order is lifted, if they could restart the work. And I guess what I'm hearing is that you don't see that it as long as some sense or common sense measures are put in place, there should not be an increased risk to the workers working on that.
Yeah, I think common sense, follow good hygiene habits, particularly with your hands and wearing the recommended current protective gear. That's what all the current recommendations are, because for right now, I don't see the risks aren't believed to be any greater than from any other, probably less than many other viruses and agents that are present in raw wastewater.
Okay. So we had another question about aerosols being emitted from wastewater treatment plant tanks. And as you were pointing out, that's something that you're going to be proceeding to study.
Yes, we're looking at that right now. We're doing a major study on that during not only at the aeration basins, but in sewer operations and other locations where there might be aerosol generation. We'll probably even look at our discharge point here just to give us assurance that we've really tested it. But we don't really feel it would be a major risk outside of any required gear or safety than currently done, but we want the assurances of that. That's what we want to show.
So there was a more general question then about, is there, we've seen there's a couple of studies being done here and in Western Europe about the presence of, the virus in wastewater as a kind of an indicator of general infection rates population-wide. And I was wondering if there was any way that any of this data could be used to look at when, stay-at-home orders and commerce, et cetera, could be reopened.
That's what the hope is in the future, is really from other studies done with poliovirus many years ago and other viruses. We know we usually can detect the virus before the first clinical cases up to 2 weeks. That seems to be what they're learning in Europe too. They started seeing the virus about a week or two before the first clinical cases. So that's one of the purposes for monitoring the wastewater on a large scale. And they were hoping to see a decrease. And so far, since the stay-at-home orders went into effect, we saw a dramatic decrease of the virus. So we believe that really had an effect. And that's how we want to use this in the future. If there's any new agents that come about, we can monitor the wastewater quickly and get an idea how fast the virus is actually spreading and the number of cases. There are studies going on now to correlate the number of cases exactly with the amount of virus in the wastewater. So you get a more precise number.
Okay, good. And I think you've answered this question, but I think it bears reiteration. So we had a question about the temperature impact on the removal or inactivation of the novel coronavirus at wastewater treatment plants.
Yeah, it's hoped that the temperature, this virus is known to be fairly sensitive to elevated temperatures. And so that's what the hope for is. Usually coronaviruses, the ones that cause a common cold, only occur in the winter. It's believed because they're temperature sensitive and the humidity changes affect their survival. And so, based on what we know about temperature effects, the virus should be really inactivated fairly readily, like during digestion of sewage sludges or elevated temperatures.
Okay. So this is a question less related to water and sort of more general health, and it is ingesting the virus any more of a concern? It's just trying to make sure I understand the question here. Is ingesting the virus any more of a concern than breathing, since this is a respiratory? Okay, so yeah, ingestion in terms of getting into the digestive tract versus into the respiratory tract.
Yeah, it's believed when you get it in your mouth, you actually respirate it, and it gets into your lungs that way. So it actually gets in it. But this virus is capable of growing in your intestines too. So if it gets through the stomach, it can grow in the intestine. But the main concern with respiratory in the mouth always has been you have to, you respirate all the time through your mouth, and it'll get into your lungs that way.
Okay. Now, then we had a question about the survivability of the virus in rivers and natural surface waters or reservoir.
Yeah, we don't know that for exact, but from the other coronaviruses, probably no more than 2 or 3 days, and maybe less than that. You have to remember when viruses like this get in, they're going to be diluted very rapidly too, if they actually manage to get in there. But for right now, our evidence indicates maybe 2 or 3 days.
And it seems like there's more and more evidence that, in fact, the UV intensity of sunlight is sufficient to kill it if it's exposed.
Yeah, that's a good point too. The UV light would damage it. Knowing the nucleic acid, the RNA viruses, this particular one, based on its RNA structure, is supposed to be fairly sensitive to UV light. So it should be inactivated fairly rapidly by UV light out in the outdoor environment.
So, that's good news. Okay, so then we have a question about any idea on Barnafo processes. Would other biological phosphorus removal process help remove COVID-19, maybe because of competition for VFAs or other PAOs?
Yeah, the Barnafo, of course, is advanced. The idea is to remove nitrogen and phosphorus before discharge. And it's very effective. It's more effective than conventional wastewater treatment for that reason. We've been monitoring the plant for 7 years, and we previously monitored the other plants with used more conventional activated sludge treatment. And these are much better for removing the viruses. Also, disinfectant is much more effective because you don't have the ammonia there anymore. So they get to add much lower levels of chlorine than they used to be able to, almost tenfold less. More than tenfold less levels of chlorine. And then, of course, they dechlorinate before discharge.
Okay. So one last question, which is one of our municipal members, one of their operators have asked, and I'll quote, when working around influent wet well pumps, is the mist in the atmosphere of higher concern in terms of a vector for COVID-19? Is there a higher chance of effective when breathing in or if the mist gets on the skin?
Well, your exposure might be greater if you're actually with that. I don't know what protective gear is recommended for that, but we are going to be looking at pump aerosols in our work in that too. So standard personal protective equipment should be adequate for that. We are going to be looking at pump operations, so I will have more information on that. I'm not quite sure how much aerosol is generated by that, but I know that's one area where we've been asked to look at.
So Charles, also in that thing, eye protection would also be recommended?
Yeah, eye protection, because the viruses like corona can be transmitted by your eyes by rubbing the virus. You can actually get the common cold or viruses by rubbing them in your eye, because your eye, there is a connection with your nose, your nasal passage. So that's how it occurs.
Okay. We had a question come in about the WEF's Blue Ribbon report, and do we have any idea when it would be released?
I thought that was supposed to be released already. I don't know.
I hadn't heard.
Yeah, as far as I know, it's done, but I'll check it out.
Okay.
May know more than me.
Yeah. Well,
Stephen, there was
yes,
one question that came in the chat, and
okay.
that was for how long after you are well can the virus be excreted in feces or other means?
Yeah, it can be excreted for at least several weeks after you're well. It's believed right now it could be up to 4 or 5 weeks even. The recent data indicates it. Yeah, that's one of the concerns. You could be excreting the virus for some period of time after you're well too. At least right now, 5 weeks is the excretion we've seen. At least 2 or 3 of those were after the person was well. So it could be a couple of weeks, but the levels decrease over that time.
Thank you.
Okay, yeah, I think that's all of our questions. So, Charles, thank you so much for taking the time to
sure.
talk to us today. We really, really appreciate it. I realize you're extremely busy, and I'm sure you're getting a lot of these offers. So we're thank you for coming to talk to us.
Okay, you take care now.
Will do. Thanks, and good luck.
Uh-huh.
Yes, thank you, Dr. Gerba, and good luck in your work. We
you.
really appreciate your time. Stephen, if you would now present Dr. Boyd Kynard.
Yes, give me a second here. I'm rearranging the boxes on my screen. Okay, our second speaker is Dr. Boyd Kynard. He is a retired research biologist with U.S. Geological Survey at the Esso Contra Andromedas Fish Research Center and is adjunct professor of fisheries at the University of Massachusetts Amherst. And he is also the CEO of BK Riverfish, which is how we met him and are working with him. He is a recognized international expert in fish passage, establishing fish passage, and he's going to talk to us about his company's unique product and how it may be used as a potential solution to secure fish passage at the Faywell Dam on the West Branch of the DuPage River in Naperville. And Charles, just sound checking that you can hear us okay?
Yes,
You're
talking to Boyd?
Yeah.
Yes, you ready? Yeah. So we'll just turn it over to you. Boyd,
Turn it over to me.
Sorry, Boyd, maybe I'm misspeaking. Can you hear me okay?
Yes, I can hear you.
Okay, then turning it over to you.
Okay. Very good. Thank you, Stephen. Today I want to talk to you about riverine fish conservation. Title of the talk is Conserving Riverine Fish Populations in Dammed Rivers, Maintaining Population Connectivity Using Upstream Fish Passage at Barriers. And this is a presentation that's put together by myself, Boyd Kynard, and my son, Brian. Next slide. The topics that I'll be discussing are the river continuum concept, stream damming, and river fish population connectivity. I'll be talking about fish ladders that pass strong swimming fish. I'll be talking about a fish ladder for poor to moderate swimming river fish that we have developed at my company. And also, so we've been talking about the dams and the characteristics of our prototype ladder that worked at this dam. And we'll also be talking about culverts, conceptual layout for passing West Duvage River migratory fish upstream at the Faywell Dam culvert using the BK Riverfish ladder. Next slide. Most people, most of North Americans are not familiar, excuse me, with the river continuum concept. This is a concept that originated in Austria, and it's a nice story about how it did originate there. But the concept is an unbroken longitudinal river corridor is needed to maintain migratory fish population connectivity. And the Austrians wrote this up in several papers, but the one that's going to be most available to most people is probably going to be this book that's featured in the lower right-hand corner of the slide. It's Fish Migration and Fish Bypasses, a conference that was held in Vienna back in 1998, and that was my introduction to the river continuum and fish migration concept. It changed my whole ecological understanding of what goes on in rivers relative to fish populations and damming. And the reason they discovered this was by 1998, there were only 2% of all the streams in Austria that didn't have dams on them. So they started building these semi-natural bypass streams around dams to allow fish to migrate. And all of a sudden, they found out that 75 to 85% of their fish species were migratory. This was a revelation. And so this is where they get this unbroken longitudinal river corridor is needed to maintain migratory fish population connectivity. They concluded that most of their species were migratory, and they need to do something about it at the dams. Next slide. So the concept is, on the left, you see a natural dam, a natural river in blue, undammed, and any fish population can move wherever it needs to move throughout the longitudinal length of the river for spawning, for foraging, for wintering. They can use their evolved migration patterns to maintain optimal fitness within that river. If a dam comes along, which is the center drawing, and blocks the river, in red you see an upstream segment of a fish population that will be created that can use the habitats that are upstream of the dam. They can also go downstream, which is illustrated by the long red arrow. But once they move downstream, they can't go back up. So now you have a downstream segment and you have an upstream segment. I've studied this in short-nosed sturgeon in the Connecticut River for 30 years and found great disadvantages to the population from having a dam, such as lower overall population abundance, a very small abundance of the upstream segment, growth differences. There are many, many, many aspects of dysfunction that this causes within the life history of the sturgeon population that I studied. Next slide. So the two views on effects of damming on riverine fish populations that you'll see. In North America, there's really no agreement that river fish migrate. So in dammed rivers, there's no agreement fish need upstream fish passage to maintain population connectivity and a functional population. In England and in Europe, they're way 20 years ahead of us. They know that their river fish migrate. They've done the studies, they have the data. So upstream fish passage is needed at dams to preserve natural migrations, population connectivity, and a functional population. And I go back to North America for just a second and say, well, how as fish biologists, how do we determine that these common river fish, the minnows, the suckers, all the various species of river fish, what do we know about their migrations? And I would say we know practically nothing. We've done telemetry tagging of a few species, large species, but who's done it for minnows? Who's done it for all the many species of minnows and dace and chubs, those guys? No, we don't have that data. The Europeans have that data, and they made the conclusion that all their fish migrate just about, so they need to provide some upstream fish passage. We're not in that position right now, and hopefully this talk will introduce you to some of this new data that we now have. Next slide. So how big a problem is damming for riverine fish in the United States? The American Fisheries Society has done surveys, and they determined that riverine fish are the most endangered freshwater fish in North America. Dams are one of the big problems for riverine fish. There are 84,000 dams in the USA, as done by a survey done by the Corps of Engineers. 75% of these dams are on small rivers with dams that are only 8 feet or less high. So not, small streams. Solution to the problem, if indeed we agree that that population connectivity is required for these populations to be fully functional in their life history, the solution to the problem could mostly be solved by a fish ladder that passed slow to moderate swimming riverine fish. There's a map from the Corps of Engineers showing the distribution of dams, and if you noticed, they're on the East Coast and the West Coast, particularly in the Alleghenies, over on the Kentucky, West Virginia, many. But there's also quite a few in the Midwest. Next slide. The existing fish ladders, they're designed for strong swimming fish like salmon, American shad, river herring. They do not pass riverine fish with a moderate to poor swimming ability. And examples of these that are very common on the East Coast for migratory fish like American shad, river herring, is the Neal fishway that you see in that lower left-hand corner. The water flow is going from bottom to top. And so you see it's just entrained air and energy dissipation as that water flows down through those slats that are on each side of the wall. This creates a very small little pocket of low velocity just above the bottom that a few fish species will swim upstream. And then another example is the Alaskan steep pass there in these two center slides. Look at those veins that come out from the walls on those things. This is also, the flow would be from bottom to top. And so they create this turbulent area inside the ladder that's full of air, but there are some fish that will go up it. Both of these were designed for salmon on the West Coast. And there's also the vertical slot, which is a concrete fish ladder on the right-hand side. And so now you get into concrete, not modular. These other two, as you can see, are modular and cheaper. But now you get into a vertical slot and you get into expensive construction. And even these ladders will not pass most of our riverine fish. Next slide. So back in 2015, after I'd retired from the U.S. Geological Survey, I was very familiar with developing fish passage. I've done this in China, Brazil, Europe, and so to me, the big need was for, could we design a ladder that would work for small riverine fish? We set as our goal the black sentence here: trials in a model alternating side baffle ladder, ASBL. You'll see that quite a bit throughout the talk. Found one design with an 8% slope that had velocities a 2-inch long fish could swim 6 to 7 inches against. It also had large eddies downstream of the side baffles. So look in this left-hand image picture that I'm showing you here. With the this is our prototype, or not prototype. This is our model. This is 1 foot wide, 1 foot high, and you can see the red arrows indicate a side baffle, and they alternate from left side to right side. And the area between the end of the baffle, of the side baffle, and the opposing wall is called the baffle slot. And so water comes down through these yellow arrows where it says flow. It hits this baffle and a little bit of it goes through that baffle slot, but it also, because of the slope of that side baffle, it comes back and creates a big eddy just downstream of that upstream baffle. And so you have these big eddies that are located just downstream of each baffle. These provide a migration route for the small fish. All they have to do is just migrate between the eddies, and it also provides a resting area for any fish that is exhausted. And so on the right-hand side, you see our total scale model ladder, and you can see the baffles going from side to side, and you can see the slope, the water as it courses down through that. He's taking some measurements. Next slide. Can you start this is a surface flow. Okay, so now we take, it's going to be difficult for you to see. I'm sorry. I thought I was going to be able to actually guide you. But you can see these eddies downstream. Can you do that again? Look just downstream of the eddies, and you'll see a big eddy. I mean, downstream of each baffle, and you'll see an eddy. It's not really. It's not really flowing like it does on my,
Yeah,
like on. Yeah, I don't know. It's not. It's moving, but. There's a big eddy right in the center of the screen right there. But it's not, the video is not doing, it's not performing. So let's move to the next one. This was a surface flow at a, there we go. That was a video of surface flow, which is duplicated on the bottom for bottom flow, which is where the fish are when they migrate upstream in this ladder at a 5% slope. Well, we've compared the hydraulics in this ladder at 5% and at 8% slope, and we find that the hydraulics are similar for slot velocity and eddy size. So we conclude that both of these ladders should pass similar fish species and of similar body lengths. Next slide. Yeah. So we use that. Laboratory stuff is good, but you'll never convince anybody that you actually have invention that will work in the real live world until you put it in the real live world. And engineers that deal with fish passage are show me people, and so you have to show them. And so here is the place that we formed a partnership between the Stockdale Mill Foundation, the Fish and Wildlife Service, and Manchester University, and we designed and fabricated a ladder at 8% slope that was 2 foot wide, 2 foot high, and 73 foot long to pass fish over this dam. And this is a Stockdale Mill Dam, Eel River, Indiana. Dam was built in 1867, and it's 5 feet high. And the dam was built to provide water to that large building on the other side. That is the mill. And I recommend anybody that's going on a tour of Indiana to stop there. That is one of the most amazing places. It's an actual operating mill that grinds 4 different kinds of grain, and it's quite a place. But I have a turbine under that mill, and it uses water that's ponded by this dam to operate the mill. So you see, you can't put a ladder on the other side, but you can put it on the side that I'm standing on from taking that picture. Next slide. So this is a picture of the design of the ladder that we put there. The bottom of it is the entrance where the fish would enter, and they would swim up this 73 foot long ladder and then swim out on the reservoir on the top side. It has curves in it because the slope of the ground from top to bottom is about 15%. So to keep our 8% slope, we had to put some curves in it. Next slide. This is a picture of our ladder. It is modular. We use pieces that were anywhere from 5 to 8 feet long, and we bolted them to the ground. You see some of the blue text says bottom anchor tab. It has a hole in that tab, and we just poured concrete, dug a hole in the ground, poured concrete in it, and put that, use that tab hole to anchor it to the ground. And so there's one on each end on each one of these. And so there are 11 ladder sections. These particular ones were 3/16" painted steel, fabricated in Massachusetts, shipped down to Stockdale Mill. And next slide. And so we assembled the 11 pieces. And this is the excavator lifting one of the pieces down for us to put together. It took 4 of us and an excavator and the operator, who you see there in the picture. It took us only 10 hours to assemble the entire 73-foot long ladder. It took an additional 10 days that was needed to finish the ladder. Next slide. And so this is a picture of the completed 11-section ladder, all anchored to the ground. And for a normal application that wouldn't be flooded, that's the way you would leave it. But next slide. Because this is built actually in the course of the river. There's normally during high flows, there are 5 to 8 feet of water over this entire structure. And so we had to put rocks in here and then put 5 or 6 inches of concrete, reinforced concrete, over this entire structure to keep it from just being washed out during the first high water event. And so you can see that at the bottom of the ladder, at the end of the ladder, the right side corner of the ladder, there's a white colored concrete right there. That's the entrance concrete that was added, and the same thing at the other end. That's the exit, and so that had to be built. And we also had to put stainless steel grate over the entire ladder. That's the completed ladder. Next slide. So the hydraulics in this 2-foot wide by 2-foot high ladder, the average slot velocity increased 35% to an average of 45.6 centimeters per second over the average velocity that we got in our 1-foot model. And the eddies downstream of the side baffles increased in size. The result was 2-inch fish could still swim 6 to 7 inches to ascend the baffle slots. There was absolutely no problem. Next slide. So, did we have any ice damage, flooding, debris? We always worry about ice damage in ladders in the north. And so, nope, we've had no ice damage. It's been there through 3 winters. Nope, we've had no erosions in 3 winters. And debris is always an issue when you talk about ladders because we're talking about maintenance. There's been no daily problem. However, after high river discharge events, a limb or 2 may lodge itself in the top baffle or 2, and you'll need 30 minutes to remove the tree limb from the top baffles, and then it's ready to go. Next slide. We monitored the fish that use this ladder, and so here you see a very primitive trap net that was put at the top of the ladder to capture fish periodically during the migration season and see what fish are using it, what are their sizes, what species are using it. And so I'll be showing several slides that come from the fish that were captured at this trap net. And so normally it would be set maybe 2 days a week for the entire period, all the way from April to November. Next slide. So in 2018, we had 59,400 estimated number of fish passed. That was 40 of 56 species that are known to occur in the entire watershed. That's 71.4% of all the fish that are in the watershed. And all the fish in the watershed are not in this river reach, and they're not really susceptible to passage, but it's still 71%. In 2019, we passed 14,000, estimated 14,100 fish passed, 39 of 56 species, 69%. Total species passed by April 2020 is 46 of 56 species in the watershed, which is 82% of all species in the watershed use this ladder. And this is the kind of numbers that the Austrians would say, yeah, just like us. We want to thank for the fish passage data, Kathy Root, the graduate student that's been doing this work with her advisor, Jerry Sweden, from Ecosystems Connections Institute in Denver, Indiana. Next slide. Some additional data that's interesting is size of fish passed, 1.5 to 20 inches long. So we got our lots of fish at 1.5 to 2 inches long. Also interesting is water depth and the minimum water depth, particularly in the ladder that fish would use, and it was 5 inches to 24 inches. And we have a little information on fish ascent speed from 37 pit tag fish, and they took a mean of 24.6 minutes to ascend the 73-foot long ladder. So around 25 minutes for a 5 or 6 inch fish to ascend the ladder. A little bit longer, probably, I'm sure, for the 2 inch, 3 inch fish. Next slide. So the species that we passed was very diverse. I've already shown you that. Many, many, many species. The dominant ones are the top 10s for 2018 are on the left. And so you look at the top 10 species and all those down to the common shiner. These are all minnows. These are all fish of the minnow family. We also had green sunfish, so sunfish family, and white suckers from the sucker family. On the right-hand side is an interesting group of fish that I thought to include. There were 6 darter species. They have 6 darter species in the basin, and all 6 darter species were passed. The reason I included them is because in most states these are federally or state endangered species. Also had rock bass, some more of the sunfish. Also had red horse, gizzard shad, catfish, and even sculpin. Now a video of fish ascending the ladder. So let's go to the next one. I hope this one will work. Next slide. Let's see if this works. Here we go. Here's the eddy over on the left-hand side. That's a baffle on your left, and these are fish that are staging in that eddy on your left and darting through the baffle slot. And then there's some guys that are right along this wall on the right, but they're not going to make it because that's where the fast velocity is. And so they'll come down and join the guys on the left. But you see the size of the fish. These are all minnows. These are all minnows. Next slide. So the prototype results show the BK Riverfish ASBO is the only technical fish ladder in North America that passes diverse small river fish. This design has provincial patent protection in the USA and Canada. Next slide. Could the BK Riverfish ladder pass migratory fish upstream at the Falwell Dam culvert? Culvert has I've misspelled Falwell. It shouldn't be an L in there. Culvert has a 5% slope, and hydraulics of an ASBL at 5% slope show that it does have the baffle slot velocities and eddies that should pass small fish. Next slide. So this is a summary of fish on the right. These are fish that were passed by the ladder by family. So there's minnows, sunfish, catfish, darter, and sucker. These top 5 families that were passed in the ladder. And then if you look on the left-hand side, you'll see these same number of species in these families that are in the West Branch of the DuPage River in Illinois. And so you see these two are very similar, very similar. Minnows dominate, sunfish and suckers are prominent. And then each one of these has some fish below that yellow line have some families that the other one doesn't have. And but for the most part, most of the fish are of the same 5 families. And the fish data from the DePage River was from the Conservation Foundation. Next slide. So here's Falwell Dam, talking about culverts now, not dams. Could you use this ladder in a culvert? So here's a typical box culvert at Falwell Dam, and again, misspelled, showing the downstream end of the culvert. And if you're going to put a fish ladder in here, you would put it on this east culvert over here on this side. Next slide. This is the upstream end of the culvert, which has floodgates that must be lowered in high water conditions to prevent flooding. And so if they were lowered and you had a ladder that came across the top of the culvert, you would need to have a removable section right there, so you could lower that gate all the way into the top of the culvert. And normally that culvert, no normal water flow in this is about 5 inches, which is operational for fish passage in our ladder. Next slide. Busy slide, but I don't know how you do it otherwise. This is a conceptual layout of a ladder, 2 foot wide, 2 foot high, 142 foot long, laid inside the Falwell culvert. And so let's see, let's look at the plan view of the ladder. This is looking directly down. You would see the entrance. Some of the text is concealed by the pictures of people there, but on that far top right arrow, that's where fish would enter. That's the entrance to the ladder. And this black line shows a stilling basin lip. Yeah, and so this area in here, just upstream of that, is a stilling basin, 50 feet long. So yes, right. And so then the ladder would be anchored to the bottom. It's very nice having a concrete anchor, yep. And it would come all the way up to the gate area where you see the protective barrier. You see it had removable ladder section, yep, right there. That's where you would have a short 3.5 foot ladder section. And then it would run along that upstream wing wall about 10 feet, or maybe 10 feet, or an estimated 10 feet. And that's where you could put a fish trap right at the end of that, so you could monitor your fish, yes. And you would also need a protective barrier along that ladder, because there's some very large trees that periodically come down the river. So let's look at the side view of the ladder. Yeah. So this is it laid on the bottom. It's at 5% concrete bottom, and you just lay it right on the bottom and bolt it right to the concrete. And you would have to put maybe a concrete ramp in that stilling basin. Yeah, this right here. Along that whole stilling basin to support the ladder, maybe a ramp 3 feet wide, something like that, that you could anchor the ladder to. So, next slide. So our conclusions are that we know we can pass riverine fish species in the Midwest. We've done it in the Eel River. It suggests that fish in other Midwest U.S. streams will migrate, and maybe it's even a greater potential than that. Maybe it's our North American riverine fish migrate. Could our ladder pass riverine fish upstream at the Falwell Dam culvert system? We think so. Okay, questions? Thank you.
Thank you, Boyd.
The end.
Yeah. Okay, with that, we're open for questions from anyone in the membership. Okay, we have a question here, and it is, Do you have any reason for a large drop off in numbers on the second year of monitoring?
That was the year, if you remember, that was the year that in the Midwest, the Mississippi and all the tributaries flooded. And it was floods that went all the way from spring to summer, late summer in some places. And so the river flows were very, very, very high. That's our only data that suggests a potential cause. All the data that was gathered during the monitoring of the fish, there was also many, many, many physical factors: discharge, river depth of water in the fish ladder. All this is being analyzed by Cassie Root, the graduate student that did the monitoring. So we'll be learning a lot more about that. But right now, that's one obvious thing that was so different. It was just high water all the time.
Okay. And it's worth, I'm just pointing out for members to remind them that, we're not, the dam is owned by DuPage County, and we're trying to not physically modify any piece of the dam. We're worried about buildability issues or constructability issues at the structure. We don't want to endanger the structure by modifying it in any way. And this, the dam itself does not have an upstream impoundment, so its habitat impacts are very minimal at this structure compared to the other dam structures that we're working on. Okay, so another question has come in, and it's longevity. How long have you had devices functioning, and what are the maintenance repairs needed to keep them functioning in experience or predicted?
Good question. That's always a question that the fish passage engineers want to know. And all we have is we put that prototype in the fall of 27. It's been through 3 winters, 3 snow melt, freezing system, freezing winters, and we've had no maintenance whatsoever. None, 0. So it looks good, but we only have 3 years of data.
And once again, it's been there through similar conditions that we would be experiencing in terms of snow, ice, and such.
Yes, exactly.
Okay. Any other questions from the membership? Okay, so then there was a question is, have you any concerns that fish will not pass through the ladder inside the culvert due to darkness?
No, it's not totally dark inside the culvert, as Stephen knows well, because he's been there. And so no, there's no concern whatsoever. Fish have an amazing ability to detect light. That we've done studies on fish, migratory fish, and find that they are inactive in darkness, but are active in 0.5 lux, which is like a candle at a quarter of a mile. So they have amazing ability to detect light that they need to orient. And
yes.
So no issues there, I don't think.
And just reiterating that on our own experience following the removal of the Churchill Woods Dam, one of the things we noted was that there was another potential barrier upstream of that, which was maybe it's about 150-foot long culvert. It's pretty, it's maybe about a 3 to 4 foot gauge, and that goes under a railway track. And there was worries that the fish would not pass through it. But in fact, that was not an obstacle. Johnny Darter moved through it within nearly instantly. So it was one of the first indicators it was working was I noted some Johnny Darters upstream of that obstacle, and there weren't supposed to be Johnny Darters in that whole 4 miles of river corridor. So obviously that kind of, for me personally, somewhat debunked the whole darkness hypothesis that we were worried about.
Well, it's a legitimate concern for people, particularly for people that they're not fish behaviorists. They've never been exposed to the literature on this subject, but I have, and in every single case, I will tell you, in every single case, it has turned out that it's not a problem.
Yeah, and certainly it was a concern of mine on the other part. I have to say it was something that
Absolutely.
at the back of my mind, but it seems like empirical testing is suggesting that they're much better at this than we had given them credit for.
Yeah, exactly.
Okay, so do we have any idea on how successful this system is versus how successful fish passage would be there if there was no structure present in the first place? Just you know, how is the ladder function in terms of fish passage versus a normal stream corridor, say at this position?
I'm not sure I understood that. It's my understanding that no small fish certainly is able to swim through the velocities that are created in that culvert. If that's
Yeah,
what that.
I'm not sure that I got the question either. I think maybe it was looking at rates. You know, are we able to mimic the success of fish moving through the river corridor if a dam was not would the fish ladder success rates be similar to an open flowing river system in terms of success based on what we're looking at in terms of the species and the structure?
We think so.
Stephen, that's the question is, I think, and Dennis can message if that's not correct. The question was like, if you had sort of a choice between the use of this fish ladder or remove the dam, would you get better success by removing the dam?
I see. Okay. Yeah, that's
Well, I think if you remove the dam, this is applicable to any dam anywhere. It's my opinion that it's always the best is to remove the dam. That's always the best. But in the case on the Eel River, that dam's not coming down. They just spent $1 million on that mill over there to make it a tourist attraction, and the dam is not coming down. They've taken down dams upstream and downstream. But this ladder that we've come up with, I think is the backup solution. If you can, take down the dam. But many dams are just not going to come down. And so as far as passing fish, there's nothing, all our data that we've gathered in the Eel River would suggest if you pass 82% of the species in the river, how can a natural thing do any better? You're still passing them. So it looks like right now that this is a very good substitute for taking the dam down.
So we had a question then about how will the eastern floodgate operate with the ladder in place?
Well, a section of the ladder will be removed so that the gates can come down. Yeah. So it won't interfere at all with the operation of the gates. None at all.
Yeah, and understanding the gate operations typically do not require the gates to be fully closed during flood mitigation operations. It's more of a maintenance type activity where they'd be fully closed.
Right.
Okay, and just so everyone is aware, Boyd was out here for 3 days with his team, and we investigated the structure through various iterations. Met with some staff from DuPage County Stormwater, ID&R, and the Forest Preserve, and talked, kicked around various ideas on how this might be accomplished, and looked at troubleshooting various parts of it, like how would we attract fish into the culverts or into the ramp system, and protecting it from debris and such. So lots of the items we're discussing, we're firming those up into a firmer proposal to take to County Stormwater and take to ID&R for permitting. I don't see any other questions. So with that, I think we can wrap it up. And Boyd, of course, will be going with a more long-term discussion to the projects committee who actually oversee the development of these projects, and we'll be setting that up fairly soon. So Boyd, any final comments?
No, thank you for the opportunity.
Well, thank you for taking the time to speak to us, and I hope
my pleasure.
Yeah, go and wash your hands. Okay, thanks, Boyd.
Stay safe.
Okay, so we are going to stop recording now, I believe.